Scientists are now teleporting stuff. Not people yet. So, don't pack your bags for Mars. But they are zapping quantum information across space like it's an episode of Star Trek. Picture this. You're sending a message so fast and secure even the sneakiest hacker would throw their laptop out the window in defeat. For years, this was the stuff of science fiction and late-night nerd debates. But now it's becoming a scientific fact. We're talking about a technology that doesn't just transfer data, it teleports it, using quantum entanglement, which basically means two particles are so connected they finish each other's electrons. And the best part? It's not just theory anymore. Labs around the world are making it happen. It's fast, it's secure, and it's giving traditional computing a serious case of existential crisis. This isn't physical teleportation. It's more like faxing the soul of a particle from point A to point B without moving the body. Here's how it works. Scientists use something called quantum entanglement, which is basically the universe's way of saying, these two particles are besties for life. Once entangled, anything you do to one particle instantly affects the other, even if they're chilling on opposite ends of the galaxy. Spooky, right? Einstein thought so too. He called it spooky action at a distance. In April 2022, a team led by the brilliant Dr. Xin Pen at the University of Science and Technology of China pulled off a mind-blowing feat. They used entangled photons to teleport quantum data over 1,200 kilometers via satellite. That's like whispering a secret in Beijing and having someone in Mongolia instantly hear it, without a phone, wire, or smoke signal. And since that record-breaking moment, scientists have been leveling up like quantum ninjas. The pace of progress? Let's just say teleportation might soon outpace your Wi-Fi. In December 2024, researchers at Northwestern University pulled off something pretty wild. They managed to teleport quantum information over a 30-kilometer stretch of fiber optic cable without interrupting the regular old internet traffic already cruising through it. Yep, quantum signals and your Netflix binge were peacefully coexisting on the same line. Think of it as squeezing a secret agent into a crowded subway without anyone noticing. By tuning into less crowded wavelengths and using super smart filters to block out the noise, the result? Quantum info glided through the chaos untouched. This is a massive game changer because instead of spending billions building brand new quantum-only networks, we might just upgrade the ones we've already got. Sounds great, right? In May 2024, scientists found something even crazier: noise. Yes, the same annoying interference we usually hate might actually improve quantum teleportation. That's right. A little chaos turned out to be useful. Using a technique with a sci-fi sounding name, multipartite hybrid entanglement, they achieved almost flawless teleportation in messy real-world conditions. It's like discovering your loud neighbor's drum practice actually helps you sleep better. Altogether, these breakthroughs prove that quantum teleportation isn't some far-off fantasy anymore. It's a real, working technology creeping into the present. And the first place it's going to make waves? Cybersecurity. While traditional encryption depends on complex math that can eventually be cracked, quantum communication throws a wrench into hacking attempts. Because if someone so much as sneezes near an entangled particle, it breaks the link, immediately tipping off both sender and receiver. Forget passwords. This is spy-proof communication. This essentially means we're entering a future where quantum communication channels are practically unhackable. Yes, unhackable. Not need a supercomputer to crack it secure, but touch it and it breaks secure. It's like having a conversation in a room where even the slightest peep from an eavesdropper instantly triggers an alarm and changes the locks. Naturally, governments and corporations are sprinting to get ahead. The European Union's Quantum Internet Alliance is already laying the groundwork for a continent-wide quantum internet by 2030. Meanwhile, China's satellite-based quantum experiments have shot them right to the top of the leaderboard in the global quantum race. Think of it as a high-stakes tech Olympics, and the finish line is total communication domination. But quantum teleportation isn't just about secret agent-level security. It's also a game-changer for quantum computing. One of the biggest headaches in scaling up quantum computers is connecting the processors. Traditional wires? Too slow, too messy. It's like trying to build a Formula One car using spaghetti. Enter quantum teleportation. No physical wires, no lag, just instant communication through entangled particles. That means quantum processors can talk to each other without ever being in the same room, lab, or even city. Take the University of Chicago's jaw-dropping experiment. They managed to teleport quantum states between processors using entangled photons. Their study in Nature Communications proved something huge. You don't need wires to build a big, powerful quantum computer. Just a bit of quantum wizardry. These breakthroughs are leading us toward the quantum internet, An entirely new kind of web where data isn't just fast, it's teleported. And it's not just for fun and futuristic YouTube videos. Imagine ultra-secure banking, faster disease diagnostics, or AI systems that can think 5 steps ahead of us. Of course, it's not all smooth sailing. There are still some big hairy challenges to iron out. But if these quantum milestones are anything to go by, the future is less Black Mirror and more Doctor Strange meets Silicon Valley. One of the biggest headaches in making quantum teleportation work outside the lab is something called decoherence. Basically, quantum information getting scrambled or lost thanks to pesky environmental troublemakers like temperature swings or electromagnetic interference. Imagine trying to keep a soap bubble intact during a hurricane. That's how fragile these quantum states are. Keeping them stable long enough to actually be useful, especially over long distances, is no small feat. Sure, teleportation experiments have made leaps using fiber optics and satellites, but scaling that up to a global quantum network? Well, that's a whole new beast. Fiber optic cables, for example, lose signal strength beyond about 100 kilometers. So, scientists are racing to develop quantum repeaters to keep the message going. Satellites, on the other hand, come with sky-high price tags and logistical nightmares. Launching and maintaining them isn't exactly a weekend DIY project. Speaking of price tags, building this quantum future is super expensive. We're talking billions of dollars poured into research and infrastructure. Like the US National Quantum Initiative's over $1 billion investment. China and the EU aren't far behind either. So, keeping quantum tech accessible and fair means a lot of teamwork and careful planning, or else we might end up with a quantum elite and the rest of us watching in awe. Still, don't lose hope. Researchers are on it, cooking up new error correction methods and hybrid systems to make quantum networks more reliable. And interestingly, some noise in the system, once thought to be a nuisance, is turning out to be a potential ally in making teleportation even better. But quantum teleportation isn't just about fancy gadgets and secure chats. It's also pushing the boundaries of our understanding of the universe. Take Caltech scientists, for instance. They're using entanglement to tackle one of physics' most head-scratching puzzles. The black hole information paradox. Basically trying to figure out if information swallowed by black holes is really gone forever or somehow preserved. So yeah, quantum teleportation is not just sci-fi magic. It's a roller coaster ride through cutting-edge tech and cosmic mysteries. And we're just buckling up for the twists ahead. Subscribe now, because who wouldn't want to teleport their boredom away?